Okay, so this is section 7-8, using exponential and log functions. We're going to use all that we've learned to help solve. You will not need any graph paper.
Yes.
So let's read through and then we'll do a couple of examples. Okay, we're going to use A equals P times e to the RT for continuous interest, where A is the amount after years, P is the principal, that's what your initial investment is, R is the interest rate as a decimal, and T is the number of years invested. Or we're going to use A equals P times 1 plus R over N to the NT power for compounded interest. So it just depends on what the problem tells us. P is the principal, R is the interest rate as a decimal, N is the number of times compounded each year, and T is the number of years invested. So let's look at number 1. Suppose that $2,000 is invested at 7.5% interest, compounded annually. So since it's compounded annually, then that's telling you we're going to be using the second equation. How many years will it take for the money to double? Okay, so your initial investment is $2,000, so that's your P. The interest rate is 7.5%, and we want to write it as a decimal, so that's going to be 0.075. T is time, that's what we're going to find. And A, the amount that it grows to, is going to be 4,000 because your money is going to double. They want to figure out how long it's going to take. Okay, so we're just going to substitute values in and solve for T. And since N is I forgot to write down what N is. N is the number of compoundings per year, and it says it's annually, so that's 1 per year. Yeah. So since N is 1, that means that this fraction, R over N, is just going to be 0.075. And my exponent is 1t, so I'm just going to put t. I'm not going to worry about it. Because it tells you in the problem that it's compounded annually. And so that's once every year. Annually is once a year. And the first thing you want to do is divide by the 2,000 so that you'll get your 1 plus 0.075 to the t power all by itself. So that's going to be 2 equals, and I'm going to go ahead and add those together, 1.075 to the t. Okay, so I want to solve for the exponent. So how do I need to write this so that my exponent will be isolated? How can I rewrite this equation? In log form, right. It's in exponential form right now. I'm going to rewrite it in log form. The base is 1.075, so I'm going to use a regular logarithm, not an ln. So log base 1.075 of 2 equals t. And so to solve for t, I'm going to rewrite this log as a common logarithm. So log 2 divide by log 1.075, and that'll be your value. So go ahead and type that into your calculator. Log 2, close the parentheses, divide by log 1.075, close the parentheses. And I'm getting about 9.6 years. Well, no, I'm not going to, but if they want you to round it different on the assignment, that's fine. Why didn't we? Because it's not base E. Okay. All right, so let's look at number 3. $100 is placed in a savings account at 5% per year, compounded continuously. So it's continuous compounding. That means we're going to use the first equation up here. How long before the balance will reach $150? So the principal amount that you invested is 100. R, the interest rate is 5%. As a decimal, it's going to be 0.05. T is what we're going to solve for. And your capital A, what the value is going to be, what it grows to is 150. Okay, so let's substitute values in. 150 equals 100, and E is your base. R is 0.05, and then T is the unknown. So we're going to solve for T, which means I need to get the E and the power isolated, so I'm going to divide by that 100. And now I'm going to rewrite this as a logarithm as well. But this time, since it's in base E, I'm going to use ln. So ln of 1.5 equals 0.05t. Okay, so let's find a value for ln of 1.5 first. Now I'm getting 0.405465, and then divide that by 0.05. And I'm getting that t is about 8.1 years.
How did you get from 1.5 equals e to the power to the next step, the ln?
Well, this is in exponential form, and this is in log form. And this is base E. That's what happened to the E.
Okay.
Yeah. Okay, anything else?